We be live, dude.
Oh,
Let us know if we're live and you guys can hear us and everything's going good. Please. We appreciate it.
please, please, please.
Did it not?
Dude, Kip, I'm so impressed with all your pictures and your cool diagrams, dude.
Dude, I don't think it's working.
But live,
Yeah.
I see us. I see
Is
us on
it the right
YouTube.
but is it the right one? That is the question,
Yeah,
dude. It is?
reflection.
Oh, okay, cool. Yep, cool. Alrighty.
And we got the I Hear You on Twitch.
Okay.
What about the YouTubes?
Uh I just heard us on the YouTube, so I think we're good.
Okay, sweet.
Alrighty, so tonight we're gonna be going over reflection.
Dude, and um, before we start, I just want everyone to pay attention to the backgrounds because most of them are taken by Kip.
Yeah.
So I'll let Kip tell you which ones are not because he's the one that took them.
So only
But
two of them are not mine, and maybe at the end that could be like an extra bonus question.
yeah.
Which ones do you think I didn't take and which ones I did take?
But anyways, they're all really cool. Part of the
So
reflection. Cool.
cool. So let's get started. Why did I go tiny? Hold on. Let's fix me so I'm not tiny. How many times do you think it'll switch back and forth? Okay. All right. So we got our first review. And already we got a challenge on the first slide here. Second slide. So if
Why does the sun form rings in the image?
ooh,
Ooh.
so if you look, right, we got like these. Ooh, let me get my laser pointer, dude. Laser. So you got like these rings that form around the sun, right? And you have this bright spot, and then you got a dark spot, and then you got another bright spot, and you got another one, and there's these.
Am I allowed to answer?
Yes.
Yeah. A, it feels like it. B, it is being bent into a ring. C, it is too bright and the camera doesn't know how to handle it. Or D, it has a diffraction pattern because of the aperture.
We got
Doo-doo-doo-doo-doo.
one D.
And if you watched last time, this should be an easy question, especially because it says review on
Yeah.
it.
So we got 1D. Do you think we'll get any other answers? Who knows?
Who knows?
Haha, no. Am I allowed to answer? Oh, the pictures thing. Yes, you're allowed to answer the pictures thing as well. I'm hoping it should be fairly obvious. So,
Yeah.
all right. So we've got the answer D twice from the same person on two different sources. That's good. At least they're consistent. Um, Jane, what do you think, dude? Should we wait any longer? I don't know. This is just a pretty beautiful picture. I don't know who took it, but man, it's pretty gorgeous. So maybe
Really cool.
we should just look at it.
Just right there. Uh, I don't know, maybe. Oh, we got more answers. D, D.
Nice. D&D, dude. And that is correct.
Cool. We don't need to roll the dice then. Or we do.
Yeah, we need a
Need to
heal, dude. If you notice,
heal.
Light's lost some health, dude.
We'll,
So
we'll take.
here, dude, we gotta go to. I
Take
forgot to
the.
pull up our dice roller. Yikes.
Oh, dude, someone's gonna hack you, dude.
I know. Dude, alrighty, so let's clear these out. Dude, my dice are going real slow tonight for some reason. Okay, here we go. Whoa! I don't know why they're going so slow, but they are. So we got 3 and 13. Dude, me too. That's what we're playing tonight. We're playing D&D. And
Yeah,
that's what the answer was, just saying. Dude, how much health should we give him 3 health back or should we give him 13?
yeah. I think that was easy.
Okay, so we'll give him
So
3.
Darn dice.
Dude, they got a little bit of health back. That's good. Alrighty, so the answer is D, and it is because of diffraction. And if you remember, diffraction is something that happens to any kind of wave when it goes through a slit or hole, regardless of whether that's an ocean wave or a yeah, light wave, whatever. And it's part of the reason that you can prove that light actually is a wave. And the reason why this happens with the camera is you've got that little tiny hole in a camera lens.
Oh, thanks, Brad.
Right there, that aperture causes diffraction. Okay, so cool. And that's why you get those kind of things. And it's that aperture is also what causes the different depths of field, and that's based on the amount of light that goes in, causing blurry or non-blurry images. Anyways, all pretty cool stuff. If you didn't watch last week, you should definitely go watch if you want to learn more about apertures. Just saying.
Really cool.
All right, let's keep moving then. So today we're going to be learning about reflection. So let's just get your guys' thoughts. Like, what on earth is reflection? Where does it come from?
Where does it go?
Why is it there?
Oh, I thought you were going to sing a song, dude.
Where'd it go?
Where does it come from? Where did it go?
Yeah, dude.
Something. I already asked that, copycats. You asked what is a reflection?
I think they did in the chat. Yeah, dude. It's already asked in the
YouTube,
chat.
the very first comment. Nice.
Nice. But
So what is
yeah,
it?
what is it?
Good.
Light bouncing off shiny things to show an image. Okay, that's great, but what is a shiny thing? Why is it shiny?
Why does the shininess help?
Yeah,
It doesn't have to be shiny.
I don't know. Question, Jaden. When you look at a color, like when you look at paint on a wall, is that a reflection?
Ooh.
Yes. Yes, it is. Okay. What about any color that you perceive with your eye?
Yeah, everything you see is being reflected to your eyes.
Oh, dang, dude.
Pretty cool.
Pretty cool.
But the reflections we kind of care about is like talking about mirrors.
Right.
That sort of thing, right?
But everything that we see is a reflection unless you're looking directly at a light, right? So, which I don't recommend. It's bad for your eyes.
And that usually hurts.
Yeah.
That usually hurts.
And maybe we'll talk about that in the next slide, maybe a little bit, who knows? But we'll just keep moving on if no one wants to think about what a reflection is, but that's cool. So let's keep going. All right. So when we're talking about reflection, there's this thing called the angle of incidence, which is the angle at which the light is coming in, is equal
from the source.
What? Yeah, from the source. And so that's the angle of incidence, and it hits something, and it's going to reflect off that normal at the same angle that it came in at. Okay.
Nice.
So, if you remember, light is an electromagnetic wave, right? And so, and if we remember, we talked about this a little bit when we talked about refraction. All objects are made out of atoms, which have electrons, which have their own electric field, and so you get this electromagnetic wave, and it comes in, hits some object, and now all of a sudden what's going to happen is it's going to excite those electrons, and that's going to make those electrons essentially move up and down and send an electromagnetic wave back out, right? Back out of the subject towards you. And so with that, you have light coming in, and some of it goes through, right? Some of it's refracted through the surface, and some of it's reflected out. Well, because of conservation of energy, and we got a great video on that somewhere back there if you want to go watch that. The amount of energy that comes in must equal the amount of energy that comes out, meaning that the reflected light and the refracted light must be equal. Exactly, dude.
Nice.
And then lastly, one last kind of important thing about reflection is there's certain angles at which light can actually penetrate the surface of something and not reflect at all, which is pretty cool. And there's a lot of
angle.
Yeah, dude. Exactly. And there's a lot of math behind that, and you can actually calculate these angles, but we're going to stay away from that tonight.
And we see those in polarized lenses, right? So glasses that have polarized lenses. Really nice, cool fact about them. If you do one perpendicular to the other, then you won't even see out of it.
Right.
If they're really good.
Yeah. Exactly. So it will only let certain light through and reflect all the other light back. So that's a cool thing. Polarized means that it's just coming in at a specific angle, right? So what a lot of sunglasses will do is they'll only let in the horizontal rays and not the vertical rays. So that way that you can actually look through water easier, because all the vertical rays that are gonna show glare are gone now. Just a cool deal there. But along with this, I do want to point out, because we did talk about this idea of like even a wall color is reflection, and the reason behind that is because that paint will absorb what all the different colors except for whatever color of light it's reflecting back out, right? And so that's why your eyes can see these different colors. That's why paints exist and all these different things, and it's why it's a little different. Like your three primary colors of paint are different than your three primary colors of light. It has to do with the fact that it's this absorption spectrum versus, just pure light, I guess. And so that's why when you add all the primary colors of that, painting colors together, that's why it creates black, because that means it's now absorbed all the light. Whereas if you add all the primary colors of light together, you get white, because now you're adding all the light together. So just kind of
there's some, what's that like really, really paint called? So like blackish.
I don't know, dude.
You know what
I don't know what it's called.
There's some cool videos about it. But it's like you shine a flashlight onto it and it doesn't even like look like you're shining anything at. It's really cool.
And
go check
it out. And that means just all the light's being absorbed into it. Okay, so that's a little bit about reflection, right? So now I've got this lovely drawing here, and we got light, and we got this eyeball, and so let's talk about it a little bit here. So if we follow one of these lines here, right? We got this line coming off light here. Boop. It hits this mirror and bounces back to the eye, okay? And remember, light goes out in every direction from something. So now we've got another ray coming off light. Boop. It hits the mirror and bounces back to the eye. And what we can see here is, so this angle, right, between the mirror and the light coming in is going to equal this angle, which is the reflected ray with the mirror as well. So it's the same thing, which is pretty cool.
You have that theta 2.
Yeah, so we got these two theta 2s, and then with the other one, it's a theta 1 and a theta 1. Kip, did you take this picture? I made this picture. I did not take it, though. Yeah. And so from there, okay, if you remember, though, Jaden, this is kind of a little weird and confusing, because if you actually look, your eyeball is, if you notice, the rays are actually diverging, right? So they started at a point at light, and then they bounce off the mirror, and they're actually now spreading apart further. And if you remember from lenses, this is a problem, right? We want them to focus together to create a single image. Which is a problem because your eye is now seeing this thing and it shouldn't be able to comprehend what it's looking at, right?
It's not focusing.
It's not focusing. It's diverging instead of coming to a point. But guess what, Jaden? Dude, our brains are so crazy smart that what they're able to do is they're able to draw this line backwards from both sides and be like, oh, dude, it converges over there.
Whoa. And that's why you see the image in the mirror.
Yep.
Nice.
So
why can't cameras do this?
Dude, because cameras ain't smart enough, dude.
Yeah, I know.
Isn't that, so that's pretty crazy that with a flat mirror, right, your eye is able to comprehend these rays that are splitting further apart, and it's like, oh, well, I'm going to calculate those going backwards, and they're going to hit at this point, so that's obviously an image.
Yeah, our brains are all doing physics all the time.
Yeah.
Every time you look in the mirror.
Yeah, every time you look in a mirror.
A lot of math.
So if we keep moving, we can... Oh, wait, we got a challenge question, though, now. So we're going to go back to that picture, but first we got another challenge question here. All right. So it's, why does a clear reflection form on a lake with no waves, but an unclear image on a rough lake? So I've got two pictures here. They're in the same spot. One time the wind was blowing, one time the wind pretty much wasn't blowing. And if you notice at the reflection of maybe you should be scared, but if you notice down here at the mountains, there's, in the reflection on one side it's not a very clear image, but on this side it's much more clear, right? So we want you to think about this idea of reflection and how there's an angle of incident and then it comes back out at that same angle, and what would happen if maybe all of a sudden your surface wasn't smooth anymore, like a perfect mirror. And go ahead and start answering away. You got, the rough water is angry, so it does not allow water to reflect. We've got the rough water allows more light to go through and less to be reflected. The rough water makes the light reflect at different angles, making it hard to create a clear image. The rough water reflects the water to a focus at a different place than your eyes? Ooh.
Ooh. Think. What do you think? We got C. We got two
We got
C's.
3 C's, dude. We got,
We got three
yeah,
C's.
dude. Oh, we got a D.
We got D. Cool.
Cool. Should we go ahead and roll the dice and then tell
Yeah,
them
let's do it.
the truth? All right, dude. Bad guy roll. Do. We got a 13 and a 4, dude. How hard is that question?
Um, I don't know.
Dude,
How hard is
dude,
that
I
question?
think we'll go with the 13. Um,
Okay.
and the good guy roll now. Do. Do we got 12 and 9? Guess what?
More people got it
More people
right.
got it right. The answer is C. So we got 12 plus 3, which is 15. So we didn't lose any health. Nice. So yeah, the reason why is if we go back to this last slide, right? You've got this straight up and down mirror, and it's gonna come in and bounce off at the same angle. But if you were to have a whole bunch of bumps in here, now all of a sudden all those angles are gonna be all over the place. And so now that's gonna send light off in every which direction. So
it doesn't ever really focus anywhere.
yep.
Nice.
Alrighty, so if we go ahead now, let's talk. If you remember, we talked about with light, with lenses, there was this idea of real versus a virtual image. And the same is true for mirrors.
Dude, Kip, you look really funny in this picture.
Yeah, dude, I know. It's a picture I took in the future.
True. Super cool.
Okay, so anyways, Jaden, we got real images, which if we remember, by definitions mean that it can be projected onto something, right? It can actually touch something. So our brains aren't that amazing, then otherwise they'd be able to do the math to make up for all the wonky angles. Well, they need to, I guess they can't predict what it's supposed to be, right? So they're able to predict some things. But anyways, a real image can be projected onto something, meaning if you were to shine it onto a wall, it would show up and hit that wall. Okay.
So you're saying it stays on the side of the mirror that it comes
right.
from. That's what that's saying.
Exactly.
Okay.
For a mirror, it's always going to be inverted if it's real. So this is kind of a crazy thing to think about. The only time you've seen a real reflection, meaning that it converges to an actual point on the same side of the mirror, is when you've only seen an inverted reflection.
So you're going to be upside down.
Yeah. Which is pretty crazy to think about because that's very rare that you actually see that.
That's pretty cool.
Pretty cool. And then a flat mirror can never make a real image. All right. So, case of your normal bathroom mirror, it can never make a real image.
Just have a non-flat mirror that makes a real
image. So that takes us to virtual images, right? So the idea of a virtual image is that the ray focuses on the other side of the mirror, so behind the mirror, right? Like in the drawing that I had. And a flat mirror is always going to be a virtual image.
Nice.
So, yeah, that whole idea of your eyes being able to, see things, I guess, and create this image that's not actually there. And that's why when you stand in front of a mirror, you're not getting like a picture of yourself put back onto you, right? Like yes, a spoon is a real image. That is a great question, and it's actually going to lead us to our next slide, which is another challenge question. And it's what kind of mirror creates a real image?
A, concave. B, convex. C, flat. Should we talk about like
What those mean?
concave gonna be
Concave's like a C,
yeah.
right? So the light's coming in this way. Woo! Convex is a backward C. Dude, how do you do that with your hand? That's impressive.
Dude, I don't know.
And then
And flat. What that is.
yeah, flat is like this. So C is concave, so the lights, or A is concave, so the light's coming in into the cup. Convex, lights going out of the cup.
Yeah, what is it? We got one B.
So just to give people out there maybe a little bit of a hint based on a question we got, which was, is a spoon a real image? A spoon, the inside of the spoon is a great example of a concave mirror, just in case anyone's wondering. The other side of the spoon that doesn't fill up with liquids would be a convex. And if you remember, for it to be a real image, we want all of the light to focus to a single point, right? So we want it to be able to focus and be reflected into a single point.
We only have one answer.
Yeah. Well, we got it. Yeah, we got an A now, so that's good.
Well, what roll the dice?
Yeah, I guess so.
Because you answered two answers, we're counting one right, one wrong.
Oh, we got another A. We got another A.
Oh, we got another A. Nice.
Dude, we get +9 health. Killing it.
Good work.
Oh, dang, dude. We're like full health now. Okay. So really quickly, we want to talk and go through the difference between reflection versus refraction. Okay.
You guys should be pros. You guys should answer this in the comments now, right? We've talked about both.
Yeah, we have. And I'll give you a hint. Both are happening in this picture. So
Pretty cool.
pretty cool.
Full help.
But yeah, just to kind of go over it real quick. Reflection, right, is the light that's bounced back off and it's reflected back out. And refraction is it's bent through the surface. And so
Spent a lot of time on that.
Yeah, we did.
Explaining.
Because it's kind of important with lenses and all.
Yeah.
And with that, Jaden, I think that it might, I guess we'll keep moving a little bit here. So the last thing that we want to talk about, and we decided to talk about reflection anyways, even though a lot of new cameras don't even have mirrors in them. Mirrorless cameras are like all the rage right now. If you do have an older camera, they do, the heck, still have a mirror in them. So if you guys can see in there, there's actually a mirror inside that camera.
Oh, nice.
Okay. And what that mirror does is on the back side here, you have an eyepiece. All right. And so what happens is before you take a picture, the light comes through the lens, boink, and it comes.
Point. And because it's a real image, because the focal point or focal length is so small, and it's a lot further than that, right?
Right.
It's going to be a small, real image, so it's going to be upside
Yep.
down.
And it's going to come in and it's going to hit this flat mirror and it's going to bounce it up a few times. And then there's some more mirrors up here. And then it's going to come out to the eyepiece so you can see what the camera is actually seeing. And then what happens is when you push the shutter, phones don't have mirrors, correct? Yes, phones do not have a mirror in them. They just have an image sensor. So when the light comes in, or when you take the picture, this mirror will flip up out of the way and there will be the image sensor right there. So the mirrors help you be able to see what the camera is going to see when the picture is taken before the picture is actually taken. Okay?
So you don't have to look at
Yeah.
upside down image. That's pretty cool.
So here's just kind of like a quick drawing and diagram of how this happens, right? So you've got this inverted image that comes in, it bounces off this mirror down here, which is, the mirror in front of the image sensor. That bounces it up, hits another mirror, bounces it to another mirror, and then that goes to your eye. So it's interesting because the light's coming in to hit the mirror, and that's a real image. But what your eye is perceiving is actually a virtual image because it's a flat mirror. But because of all these reflections and bouncing around that happens, you actually are able to rotate this picture so it's facing the right way again so your eye can see it properly.
So when we have cameras without mirrors, you say the image sensor does that work for us. So when you're looking through the camera, you're looking at the image sensor, or what are you looking
at? Yeah, exactly. So there's a lot of limitations to just having the mirror, and we'll get into this more next week. But when you just have the mirror, the only thing that you're able to see is the light coming through the lens and then going to your eye. But the thing is that cameras are digital and you have all these different things that you can adjust, like shutter speed and your ISO and these different things to create a brighter or darker image that just a simple mirror can't calculate. But the image sensor can actually tell you what it's going to look like before you take the picture. And so, like when you have your phone camera out, what you're doing is you're just essentially getting a live feed from that image sensor. And it will just calculate what the picture is going to look like. Essentially, what you're getting is just a video. You're just getting a whole bunch of pictures taken really, really quickly. And that's what you're seeing when you take a picture on your phone.
Okay.
So you don't have that mirror. So, yeah, guys, that was tonight's lesson. A little quick, a little fast, not a lot of math, just quick, simple, to the point. Next week, if you guys are interested in staying tuned, we will be going over how light is no longer going to be a wave anymore. So this whole class,
What?
we've talked that light is a wave and how it follows all these principles of waves just great and grand, and it abides by them perfectly. But guess what? Next week,
It is also
light
a
is no longer going to be a
particle.
wave, but it's going to be a particle, which is what Newton thought light was back in when Newton was alive. And then everyone was like, nope, you're wrong. And he's still pretty wrong. But he had some
Yeah.
right ideas. And one of the reasons why he thought that is because of this idea of reflection, which is when a particle in actual Newtonian mechanics, if you throw something against a wall, it will the angle of incidence equals the angle of reflection with a bouncy ball. So that's very similar. Anyways, so next week we'll learn
Um,
about something you guys may have heard of a lot, which is the photon.
do, do,
Do do
do.
do. And why that's important with cameras? Well, guess what? Spoiler, it has to do with the image sensor. So, check it out.
Do.
Thank you all for watching and have a good rest of your night.
Yeah. See you later.
See ya.